We present SecondSkin, a sketch-based modeling system focused on the creation of structures comprised of layered 3D volumes. A defining aspect of layered modeling is the geometric dependence on underlying layers, on and around the subsequent layers which are drawn. Our approach is built on a few novel insights. A closed loop of strokes, sketched from a single viewpoint, typically defines surface patches that bound volumes with underlying surfaces. A majority of these strokes map to a set of 4 curve types that describe their 3D geometric relationship with underlying layer geometry, and these strokes are robustly classified using a few geometric features. We transcend visible surface modeling to produce 3D solid models comprised of closed volumes. These volumes are bound by spline surfaces, easily represented using hexahedral elements and suitable for further physical deformation and simulation. Users of SecondSkin simply draw as if on paper, using typical digital sketching and editing functionality. The 2D strokes are inferred in 3D relative to the geometry of the active base layer. Other geometric layers, if present, are passive and simply a visual reference. Closed loops of curves are automatically detected, surfaced, and optionally turned into a volume bounded on the other side by the underlying geometry. Users can hold the Shift key to invoke alternate interpretations to classified strokes. We present a set of 3D curve types commonly drawn when depicting layered structures and an algorithm used to classify and infer the shape of sketched 2D strokes. These curve types can be robustly classified by simply observing the 2D spatial relationships of sketched strokes relative to the underlying geometry. We validate our approach with a perception study of 15 viewers classifying 40 strokes over 5 examples. Our curve type classification is not infallible, but it is predictable and can be easily understood by users, allowing them to redraw without frustration when an unintended classification occurs. Curves which fall outside of our classification can be created from context by anchoring strokes to known 3D positions and classified curves. We also provide interactive techniques for surfacing and volume creation to speed up the modeling process. We provide surface envelopment for creating rings and extrusion for lifting volumes from surfaces. Salient features and occluding contours of underlying geometry can impact a viewer's perception of a drawn stroke. To improve classification, we perform a 2D shape matching step between drawn strokes and prescribed feature curves. Here are some results made by an artist. Here are some results from a group of non-artists.